Sorry for letting you wait. So, I'm Tommaso Teofili from Adobe. I work with the R&D in Basel. I'm also a member at the Apache Software Foundation and working since 2009 with this project called UIMA. And today I'm going to introduce you a very small use case which I think is interesting in terms of OSGI adaptation and which approaches could be used when you come with an existing framework or something that's never seen an OSGI container before, and you want to adapt to it or want to let it run inside such a container. So the agenda is we're going to see the problem. So it's very easy. We have not OSGI stuff which we want to run in a OSGI container, and also a very nice thing would be to have such thing leverage also OSGI capabilities. We are going to do that via use case, something that I've done myself. So going through the possible approaches that we can use for adapt such a framework, and some conclusion with lessons learned and some things that we have left out. So this is our use case, a tool called Domeo from a friend of mine at the Harvard Medical School. It's basically an annotation toolkit. So it's something like you have this tool and you have medical documents and you want to annotate using ontologies and something that doctors and researchers have put in such knowledge bases. But the cool thing this tool does is that it enables to also do some kind of semi-automated analysis of the text in order to tag some, for example, text as diseases, or to reference some publication, something that is very useful for researchers. But well, that's not our business. What we focus is that we're going to deal with it because this uses Apache UIMA for the text mining stuff, so the semi-automated analysis. But they need to integrate with these ontologies via RDF models, and so they chose this Clerezza platform, which is another Apache project. And so Clerezza is OSGI based, while UIMA is not. So that's our problem, and the use case that will drive this discussion. So briefly, Apache UIMA is an ASF top-level project since 2010. It's an architectural framework for unstructured information management. It's also a standard and powers lots of very cool stuff. And it's used for pipelines of analysis, something like that. You have different building blocks with algorithms to analyze text. And yeah, the cool thing is also that you can use it to scale for large amounts of data. What is Apache Clerezza? Is an incubator project, and it's a service platform for linked data, providing an RDF API with JAX-RS implementation, so a RESTful framework. And it's based on OSGI, and it powers another Apache project called Stamble. Okay, so very quick introduction, and that's the architecture that we're going to deal with. We have HTTP request on the JAX-RS layer, with in our use case with Domeo, something that we want to be analyzed from our pipeline. So those text gets passed to the pipeline. The pipeline, the UIMA pipeline, produces something that needs to be converted in these RDF models based on some annotation ontology that is a kind of ontology, and eventually persisted on the triple store. Okay, so the problem is Clerezza is OSGI based. Artifacts are delivered as bundles, obviously. UIMA is not OSGI based and not OSGI ready. That means that you can't just get one of the UIMA jars and install it on Apache Felix, for example. because of some problem with class loading, which we'll see later. Artifacts delivered as standard jars or peers. So it's using reflection and custom class loading for doing something, but also as some OSGI artifacts for their plugins for Eclipse. So it's kind of strange because it's not OSGI ready, but they have some very particular stuff for the Eclipse plugins. So our problem, how to flawlessly let UIMA live and run inside Clerezza. So when adapting to OSGI, we need to consider kind of backward compatibility, development effort, class loading, packaging and deployments, semantic versioning at least. But the very important thing is our business requirements, which drive the order on such list. So at least in my experience, it's usually when you adapt something or you create something from scratch to OSGI, you have to care about backward compatibility, but you can let them be in some way get over. But in this case, in the use case we had with UIMA, we couldn't, because we have a long history of a long project which has a lot of production installation and big companies using it, and so we have a problem, or we have a strict requirement on backward compatibility. So possible approaches, what we can do to solve our business problem. Migrate everything to support also OSGI. So this is in theory, but we will see that's not our case. So just grab the code base and start writing the OSGI way. So start changing the artifacts to be delivered as bundles, implementing services, whatever. We could adopt a slightly different approach to migrate something in a single lightweight bundle, something like a lightweight approach in order to not interfere too much with the existing code base. Or just, the lazy approach, migrate nothing and wrap something in all the code base in a big, all the artifacts we have in a big bundle. Not good. And the final thing, create an adaption layer. Or maybe other approaches, but these four are, the main. Approach one, migrate everything. So I take the code base and migrate to OSGI. It's OSGI compatible. It's a one-time effort, at least to do the very first migration. You can fully leverage OSGI capabilities because you don't care about what happened before. We are just migrating to OSGI, and that's it. But we have backward compatibility issues. The development effort may be very, very huge. We need to consider integration effort, because if our framework is deployed in different platforms with different customers, that could be a problem. If we're going to keep different both the code base, the old code base and the new one, we need to maintain different architectures. And it's not always feasible because you need full control over the code base. So we'll see why. Migrate something. So take a small subset of the functionalities and put it in a lightweight bundle. It's kind of a facade package, easier limited development effort, but again, we need to keep maintaining OSGI and not OSGI stuff. And a big concern is that not everything is available to OSGI client architectures. So, and again, we need full control on the code base. The just wrap approach, almost no development effort. We just create a new, for example, using the Maven bundle plugin, we create a new project. We just embed all the dependencies or try to, do something like that with BND tools or whatever. But it's very simple. In terms of APIs, you just can expose everything so that everything is available to OSGI client architecture, but you're just not leveraging OSGI capabilities. You may have possible class loading issues because our framework could have those with OSGI, and still we need to keep managing these two things. The fourth approach is an adaption layer, which has the good thing that everything is available to OSGI client architecture. The original not OSGI stuff is not touched, so we're developing an upper layer. No need to control. And the concept is that we have some application-specific development, and we need an expertise on the application. We can explicitly manage class loading issues, but that's something we have to do, and need to keep managing such a layer. So again, back to the requirements. So here is our approach, our list of approaches that we can use, but Domeo concerns OSGI compatibility. We just want the UIMA developers to almost do nothing because they knew UIMA and they don't want to learn a new framework, new things. And we also want to leverage OSGI capabilities. At the same time, the community's concerns. I was, just to say, I was the man in the middle because I was committer in both of the projects. I am committer in both of the projects, and but also helping my friend at Domeo. So I couldn't just force the two communities to get my way and my use case because it's not something that is for the community, but it's just one single use case. So the UIMA community was interested in OSGI, but not willing to drop backward compatibility, not willing to migrate everything to OSGI right away. While Apache Clerezza community was happy to have UIMA integration on board, but didn't want to have release blocked by the OSGI adaption stuff. So feasible approaches, just to go straight, the adaption layers seemed to me the best one because I had some OSGI experience. I knew both the frameworks, and so it seemed that it was the most important thing. We just didn't touch the code bases. And so that's the way we chose. Talking about the adaption layers, these are the known approach. There is this tool, Dynamic Model Enablement for UIMA from IBM AlphaWorks, because UIMA is a former IBM project which was donated to the ISF back in 2006. So they have something on AlphaWorks, but it's not kind of open source. There is a UIMA integration for Apache Stumble, which also uses OSGI. There have been some discussion on the UIMA mailing list of using Maven automatic dependency resolution for supporting OSGI. And there is the Clerezza UIMA integration module, which it's what I've done. So this is the thing from IBM. It's kind of complicated, not that complicated, but not lightweight. So it's not something that we're interested or we weren't interested in for our project. So our adaption layer, based on this Clerezza UIMA integration, just add a simple API on top of the UIMA API, so that newcomers can just use that. But still, you can use the full UIMA API that you add if you are going to use UIMA without OSGI. And we have just one constraint, that each bundle using UIMA just needs a specific OSGI activator. So let's take a sample service that we're going to develop for the Domeo use case. So consider an existing text mining application using UIMA for some NLP task that needs to be plugged into Domeo. It needs REST endpoint, RDF API, annotation ontology, model awareness, but it already has one or more UIMA descriptors for its pipelines, UIMA components developed internally or taken from some other projects. And so let's assume our sample service. Let's get this sample service that has one descriptor and uses another open source project called Apache OpenNLP for doing the pipeline and then NLP task. So that's our very simple scenario. What we can do with Clerezza UIMA is like that. We have some tags, some annotation for the JAX-RS implementation. We create a UIMA executor. We analyze, and we just pass a URI that gets from the request to our executor, which analyzes the text with the descriptor that we have in our bundle. Very easy in terms also of code. Nothing really complicated. So what are the dependencies? Because we are going to see that we'll have some problems with class loading. So we have here that our sample services has two dependencies from the Clerezza UIMA utils, which is our adaption layer, from OpenNLP, which has the components for analysis, while the Clerezza UIMA utils has dependency from the UIMA SDK. So these two are bundles, so SGI bundles. These two are not. Okay. So the sample service has OpenNLP stuff in its class loader, gets UIMA stuff from the Clerezza UIMA utils, that is the adaption layer. Nothing new. But UIMA uses XML descriptors in which the component-specific class name are given for the pipeline instantiation. So here again, a nice descriptor, OpenNLP UIMA name finder class needs to be retrieved from OpenNLP. So UIMA SDK uses the infamous class for name, and so everything should break because we have this circular stuff where this needs our sample services need something from OpenNLP. The Clerezza UIMA utils need something from the SDK, but this is just needing class. It's not dependency, so it's not something that it's not known to the bundles or to the artifacts or to the container. So we have this dependency which breaks our scenario. So we can leverage OSGI activators and UIMA resource manager. Because UIMA likely can be the UIMA framework can be decorated with some custom resource manager which can hold their specific class loading stuff. So we take advantage of such things. So each bundle using UIMA extends a specific OSGI activator to explicitly declare its UIMA components. The Clerezza UIMA utils module registers such component class loader within an aggregated class loader, which is passed to the UIMA resource manager at runtime, which is kind of tricky, but this picture should help us. So this is activation, okay? So we have the UIMA component X in our sample service bundle. The UIMA bundle activator has a reference to this, which is an OSGI service. That's the reason why we have this service registry reference here. So it registers that component there. At runtime, the OpenNLP sample services just uses a descriptor, so it doesn't pass this component. It's just in this part of the box. So the UIMA executor has an object called the HEY provider, which is the analysis engine provider, which as a resource manager, which has a hook to the UIMA resource class loader repository, which is the service. And so it can use such class loader, which contains reference to this one, to just not break when instantiating with the infamous class for name stuff. So it's kind of tricky, but it's a trick that works. And the cool thing is that it enables us to just not touch the UIMA code base. It's fully OSGI compatible. It helps us being lightweight in our framework. So we don't have to do some custom things, custom service registries, whatever, something that is in the IBM stuff. We have some left outs that, well, for our at the integration time were not that important, like semantic versioning, and some more OSGI capabilities could be leveraged. Because the UIMA API is, in my opinion, is very well suited for OSGI in terms of services that it exposes in granularity, but it's something that maybe will be done in some other way on the UIMA side. So lessons learned, not only one good way. Full OSGI migration is often not simple in the enterprise because you just have something that never saw OSGI. Using BNT tools and Maven bundle plugin is sometimes not enough because we don't know, or we should know at least, what our framework is doing under the hoods. And if we have some class loading, custom class loading stuff, we may have everything broken. So it's something that need to be handled some way. And so, just one last thing, I was obliged to put that on that slide. Sorry. So if you're interested, Adobe Basel is hiring, and if you have questions, yeah, I'm here. I think I have 2 minutes. So.
So our approach was basically the same.
Yeah, really? I didn't see the code, but I just see diagrams.
The only difference is at that point in time there was no exposure of the bundle context. So whenever you had a bundle somewhere, you had no chance of obtaining the class loader. So you had to inject code that has an activator that exposes the class loader to be able to access this class loader and load the classes. Also, UIMA has a problem with the JCAS. The JCAS is basically a type system, and that one is shared among each annotator. So whenever you introduce an annotator, all the other bundles have to know about this JCAS.
Yeah.
And it is not split, so it's not modular in its core.
Inherently.
Yeah.
Yeah.
And this is the fundamental problem with UIMA and OSGI.
Mm-hmm.
And this is not solved yet. And to be honest, the problem with adapting OSGI, we had that 5 years ago, and I don't think that will go away because the people working on those modules are basically linguists. They are not computer scientists. To motivate them to adapt anything that makes their world harder is virtually impossible.
Well, but believe me, I've had lots of discussion on the mailing list about this OSGI stuff to just convince them that it was worth doing it. And I could see some interest and someone trying it out, but honestly, yeah, I also can see the point of the linguists or the people which, yeah, actively works with it. They not wanting another complexity or, yeah, but yeah. I think that's just a use case to highlight what could happen, and yeah, but I think it was a nice experience. Thanks.
Okay.
Thanks.